Our today's topic is on distance time graph, displacement time graph, uniform velocity, velocity time graph, which is the continuation of the previous video, that is on distance, displacement, velocity, and speed that we did last class. Now, let's start from this distance time graph. When you are asked to define distance time graph, it means the graph of distance against time. That is the graph that will have distance on vertical axis, then time on horizontal axis. Let's say you have something like this. This is our vertical, this is horizontal. So this is distance in meter, this is time in seconds. So if you have, after plotting the graph, you have your graph like this. In order to find the slope, you are going to choose 2 points. Like let's say this is point 1, point A, this is point B. Then you trace the point to horizontal, which is T1. Trace the second point to horizontal, that is time axis, that will serve T2. Then do the same thing for vertical, that will serve as D1. Then this one is your D2. Then make it a right angle triangle here. Then you find the slope. Then you now say the slope is equal to change in what you have in vertical, that is distance, this D1, D2 minus D1 over the horizontal, that is T2 minus T1. So this one can be written as change in distance over change in time. So if this change cancel each other, so you are going to have distance over time. And don't forget, what is distance over time? Distance over time, according to our previous topic, distance over time is speed. Therefore, the slope of distance time graph gives speed. Now, let's move to the next topic, which is what? Displacement time graph. So when you are asked to define it, it's the graph of displacement against time. So in that case, our vertical axis will be replaced with displacement. We have displacement here in meter as well, while time will still remain the same. Then we are going to have change in displacement. When you are looking for the slope of this now give you change in displacement over change in time. Then if this one cancel this, so we are going to have displacement over time. And don't forget, according to our last class, displacement over time gives what? Gives velocity. Velocity. So the next subtopic is uniform velocity. So our velocity may be uniform or non-uniform. Now let's try to use this table to justify. Let's say we have a car or an object that starts its journey from A and is going to L. Now, from the distance covered from A to B is 2 meters, while time taken is 1 second. Then for C is 4, time is 2 seconds. For D is 6 meters, time is 3 seconds. For E is 10 meters, time is 5 seconds. While F is 20 meters and time is 10 seconds. Now let's try to find the what? The speed, the velocity, because it's displacement and time. So for this one is 0. For this place, this divided by this will give us what? 2. This one is also 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 2. So in that case, we say the velocity is uniform. The velocity is therefore both initial velocity and final velocity, they are equal. Let's try to see this one. Look at it, this position, but the velocity in the first second position is 2, while the second one is 1.33 and the third one is 1.5. You can see they are not uniform. So this one is called non-uniform velocity. Non-uniform velocity. Now, the next topic is velocity time graph. Velocity time graph. When we say velocity time graph, like we did in case of distance time graph and displacement time graph, it means the graph of velocity against time. where we are going to have velocity on vertical axis, then time on horizontal axis. We have it like this. So this one is velocity in meter per seconds. Then this place is time in seconds. So when you plot your graph, you have it like this. So this one means the velocity is increasing. You can see from 0, as we are going up like this, velocity is increasing with respect to time. Now, what are the things you can determine, or you can derive, or you can get, or you can determine from this velocity time graph? The first thing, you can find the slope. And what will be the slope of velocity time graph? Let's try to get it. The slope. So do the same thing. You have one point here. Trace it down. This one we serve as T1. Then another point here. Trace it down. We have T2. Then trace this one here. This is V1. Then trace this one here. This is V2. Then join this one to form right angle triangle. Therefore, our slope will be changed in what you have in vertical axis, which is V, velocity, over change in what you have horizontal, that is T. So if this one cancel this, therefore the slope of velocity time graph will give us velocity over time, or change in velocity over time. So, and what is velocity over time? From our previous class, that is when we are dealing with fundamental quantity and derived quantity. Velocity over time gives us what? Acceleration. So this one is acceleration. Therefore, the slope of velocity time graph gives acceleration. Now, let's try to see the different type of velocity time graph. We have almost 3 parts of velocity time graph. Almost 3 parts of velocity time graph. You have the case where the velocity of the car or of body will be increasing. You have it like this. So if the velocity is increasing, you have your line like this, and that's what we call acceleration. This is velocity and in meter per seconds. This is time in seconds. So when velocity is increasing, you have it like this. This line is called uniform acceleration. Then we have another part when the body, a car will be moving with what? Constant velocity. Constant, like what we did in this graph. Constant velocity. That is, the velocity here, the car will maintain this velocity. If this one is 2, so it will continue with what? 2 like this. We call it constant velocity or uniform velocity. That is case 2. Case 3 is when you are about to stop, you apply brake. What will happen to the car? The car will be getting what? Slowing down until it will come to rest. And you bring it down like this. And that is what we call deceleration. So this one is called acceleration. While this one is called uniform or constant velocity. Then this place is called retardation or deceleration. So these are the 3 major parts of velocity time graph. Velocity time graph. Now, when a body moves with uniform velocity, what happens to that? The acceleration of that body. Don't forget, the formula for acceleration is change in velocity, which is v1, or that's v2 minus v1 over t. Then when we now say the velocity is constant or uniform, it means this one and this one, they are going to be equal. If this one is 20, this one will be 20, like what we have here. Therefore, the acceleration will be 0 over time, and 0 over whatever you have as time will give you 0. Therefore, is under uniform or constant velocity, acceleration is equal to is 0. So another thing you need to derive under velocity time graph is the area. So in some cases they may ask you, after plotting the graph like this, they may ask you to find what? Total distance covered. You don't need to apply any formula. Then the total distance, look at the shape. The shape looks like trapezium. So the area under velocity time graph is equal to total distance covered. We have two things now. The first one is slope of velocity time graph gives acceleration. The second one is the area under velocity time graph gives total distance covered. If you look at it like this and you don't know the type of shape it gives, so you can divide it. This one, that will be A, B, C. So in that case, you are going to look for area of triangle, area of square or rectangle, area of triangle. Again, you have the three together, or you take it at one. So whatever you give will give you total distance covered. So inshallah, the next topic will be equation of motion.